The last way we're going to learn to solve quadratics is the quadratic formula. So if you have something in standard form where a is first in front of the x squared, and then you have bx, and then you have c, we're going to take each of those numbers and plug them into the quadratic formula, which goes like this. Negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So fill those letters in. I have color-coded them, but whatever those numbers are, we're just going to plug them in and then simplify that equation to get the two answers. We use the quadratic formula when we can't factor, and if you're not so much of a fan of completing the square. So if you don't like completing the square. The quadratic formula works no matter what. It might take a little longer, but it will always get you to the correct answer. So first I'll identify A, it's 2, B is 3, positive 3, and C is negative 5. Now I'm going to plug into the formula. Everything in the formula that I have up in that box that's written in black, I'm going to write in black. So the formula goes negative b, so it's going to be negative, and then inside parentheses, I'll put the number for 3. And then it's plus or minus the square root of, and in parentheses, we need to square b. So 3 squared minus 4. And then in parentheses, next to the 4, we need the number for a. So 2, because a is 2. And then the number for c, and c is negative 5. And all of this is divided by 2 times a. So 2 times 2. So this might look like a lot for you to solve, but I'll help you through it. What we're going to do first is we're going to solve everything underneath the square root first. So everything I just circled in yellow, that's our first job. And the rest of it we can simplify along the way as well. So this negative 3 out front, I'm going to put negative 3, negative 3, plus or minus the square root of, all right, 3 squared is 9, and negative 4 times 2 is negative 8, and negative 8 times negative 5 is positive 40. So underneath the square root sign, I have 9 plus 40, which is 49. All of that is on top of 2 times 2, which is 4. So everything circled in yellow came out to 49, and I just showed that work off to the side over there. Next, we're going to square root the 49, and that happens to be a perfect square. So we're going to have negative 3 plus or minus 7 divided by 4. So now we're going to have two answers. We have to figure out the top. We have to figure out negative 3 plus 7 and divide it by 4. And we also need to figure out negative 3 minus 7. Negative 3 minus 7 and divide it by 4. Those will give us our two answers. So negative 3 plus 7 is positive 4, and 4 over 4 is 1. Negative 3 minus 7 is negative 10. And when we reduce negative 10 over 4, we get negative 5 over 2. So the two answers are x equals 1 and x equals negative 5 over 2. My hint right here is that your whole equation has to be in standard form. So everything has to be on the same side of the equal sign. So let's fix 1b. I'm just going to move the 2x over. I'll subtract it from both sides. And I know that the x squared has to come first, then the minus 2x, and the minus 3 will come last so that it's in standard form. Now everything's on the same side. And I'm going to go ahead and label A, B, and C. So A is 1, it's right here. B is -2, and C is -3. So I'm going to plug those into the formula. So I will write negative, and in parentheses the number for B, which is -2, plus or minus the square root of, in parentheses squared, I'm going to put B again, so -2, minus 4 times A times C. So A is 1, C is -3, and all of this is over 2 times A, which is 1. So we're going to take everything underneath the square root sign, all of that, and we're going to simplify it down to one number. So over here off to the side, -2 squared is 4, and then -4 times 1 is -4. -4 times -3 is +12. So altogether that equals 16. So everything else I'm going to recopy. -2 is +2, plus or minus the square root of, and now we know all of that underneath equals 16. And we're going to divide it by 2 times 1, which is 2. So next we're going to simplify the square root of 16. So this is going to be 2 plus or minus 4, because the square root of 16 is 4, divided by 2. So now I have the two problems. The first problem is 2 plus 4 divided by 2. And the second problem is 2 minus 4 divided by 2. So 2 plus 4 is 6. 6 divided by 2 is 3. 2 minus 4 is -2, and -2 over 2 is -1. So those are the two answers. That's what x equals. On the next one, everything's set equal to 0. So A is 1, B is 10, and C is 2. So in the formula, it's -b, so -10, plus or minus the square root of, in parentheses squared, b squared, minus 4 times A times C, all divided by 2 times A, which is 1. So next we'll simplify everything underneath here, and that's going to be 10 squared is 100, and -4 times 1 is -4, -4 times 2 is -8. So 100 minus 8 is 92. So that's what will be underneath the square root sign. So out front we have a -10 plus or minus the square root of 92, and this is all over 2. So now we have to figure out what the square root of 92 is. Can we factor tree 92? Well, since it's even, I know we can divide it by 2. So 2 times 46 equals 92. And 2 also goes into 46, 2 times 23. So 2 is prime, and so is 23. So it looks like we have a pair of 2's, so that's going to simplify to 2 square root 23. So that's what we're going to put for the square root of 92. So we'll have -10 plus or minus 2 square root 23, all divided by 2. So this is a little different because I know I'm not going to be able to add the 10 and the 2 square root 23. So I'm going to try dividing by 2 as much as I possibly can. So I'm going to put the -10 divided by 2 as its own fraction, and then I'm going to put plus or minus 2 square root 23 over 2 as its own fraction. And we're just going to simplify as much as we can. -10 divided by 2 is -5, And this 2 on top and the 2 on bottom, they cancel out. So then we're just left with plus or minus square root 23. And that's how you write your final answer. Try getting as far as you can on this next one, and then I'll help you out at the very end so you can simplify your answer correctly. So if you got negative 3 plus or minus the square root of 37 over 2, your next step is to break apart the real part, well, the non-square root part, and see if we can simplify that, and then plus or minus the square root of 37 over 2, and see if we can simplify that. We actually can't. We can't do anything else here. So this is the final answer. These problems are going to be the same. We're just going to get imaginary answers. So I have A, B is negative 1, C is 2. So it'll be negative 1 plus or minus negative 1 squared minus 4 times 2 times 2, all over 2 times A, which is 2. So let's simplify what's underneath right here. Negative 1 squared is 1. That'll be negative 8 times 2, so it'll be 1 minus 16, which will be negative 15. So out in front, this negative turns to a positive, so I'm going to have positive 1 plus or minus the square root of negative 15. And all of that is over 2 times 2, which is 4. So I know I'm not going to be able to add 1 plus the square root of negative 15, so I'm just going to separate into the 2 different parts. 1 over 4, I'll see if we can simplify that, plus or minus the square root of negative 15 over 4, forgot my negative sign, negative 15 over 4, and now let's see what we can do. I can't do anything to this 1 over 4 in front, but the square root of 15, the square root of negative 15, can I factor tree 15? No, I can't reduce that square root sign, but I can pull that negative sign out and make it an I. So the square root of 15 will stay the square root of 15. We can't reduce anything with the 4, and that negative sign will become an I, and we put the I at the very end. So that's the final answer here. If you got the next one down to this step, all we need to do is separate them. So we have 1 over 6, we can't reduce that, plus or minus the square root of negative 95 over 6. So let's simplify that as much as we can. We can try to factor tree the 95, but we're not going to get any pairs, so all we need to do is deal with that negative sign. So the final answer here will be 1/6 plus or minus the square root of 95 over 6 with an I next to it. The last thing we're going to learn is how many real zeros we have. We're not going to find where they are. We just want to know how many real ones there are. If there aren't any real ones, they're going to be imaginary. We use something called the discriminant. The discriminant is the part of the quadratic formula that's underneath the square root sign. And all we need to do is calculate b squared minus 4ac. If that is greater than 0, in other words, if we get a positive number, it means we're going to have 2 real solutions. So you'll be able to abbreviate your answer. You could say 2 real zeros. If your discriminant equals 0, if you actually get 0, it means that you have 1 real zero. And that's how you can abbreviate it. And if you get something that's less than 0, so if you get a negative number for the discriminant, that means you have no real zeros. No real zeros. And we know if they're not real, it means that you have 2 imaginary zeros. So it's the kind of parabola that floats. So all we need is b squared minus 4ac. So A is 1, B is negative 6, and we need to move that negative 7 over so that everything's in the right form. So x squared minus 6x, when we move it over, it'll be plus 7. I started working too fast. So A is 1, B is negative 6, and C is 7. So B squared, so negative 6 squared, minus 4 times A times C. Let's see what we got. We're going to have 36 minus 28. That gives us 8. Since 8 is a positive number, this means, since it's positive, it means that we have 2 real zeros. So you can say 2 real zeros. And that's all. That's all we wanted to know. We're not figuring out where they are. We just know that your parabola looks like that. All right, let's see if you can figure out 3b. First, you're going to need to make sure it's in standard form. So first, you're going to need to bring the 9 over. Hopefully, you moved the 9 over and you knew that C was positive 9. So you ended up with 36 minus 36, which equals 0. So this is the kind like that's in the middle. We're going to end up with 1 real 0. So that's our answer, 1 real 0. Last, figure out 3c. In 3c, we got negative 8 for the discriminant, which is like this third kind. We have a negative number. That means we have no real zeros. It means we have 2 imaginary zeros. They are floating. That's it.